Sonification and other stuff. Oh, that's cool. That's cool. Oh, and let me stream on Discord. Always forget to do that. One sec. Share my screen. There we go. What's up, Jack? Can you hear me, Jack?
Hi.
Hey, Jack. How's your 3-day weekend going, dude?
So can I be the first person?
You can always be the first person. You be the first person. Yeah. You got a question?
Yes.
All right, dude. Dope, dude. I like that, dude. That's cool. What's your question about?
Can we do fractions?
We can totally do fractions. Here, let me start the stream and announce everything, and then you'll be first up. Is that cool, Jack?
Okay.
Okay, cool. All right.
Put my name in it.
What's up?
Put my name in it.
I will put your name in it. Yeah, I'll do it. Okay, cool. Here we go. All right. Welcome, everyone, to Office Hours. My name is Dr. Gold. This is Actual Education, where the student helps you out with math homework, science homework. I'm joined by Jack. Jack, you've been here for a while, dude. Jack, you've been in our Discord for probably like a year and a half, maybe, right?
Yeah.
Here. Yeah, cool, dude. Nice. Yeah, it's a 3-day weekend. I'm still streaming, though. Still helping you guys out. I thought about canceling today and just having a barbecue, but I was like, nah. Okay, we gotta help people and stuff. Yes, okay, cool. Also, yeah, if you guys want to still get help, but you don't want to do it on the stream, or if we run out of time and whatnot, we have a text chat bot that will help you out with math and science homework stuff. So you can always ask.
It will not help you with science.
It's too stupid for science. All right, it'll help you with math. You check it out. It'll help you with math. If you do, I think !AI. There you go. That should give you the link for it right there. If you guys ever, you can still earn bond coins with it too. So just go there and show me a screenshot at the end if it helps you out and whatnot. And
I have a question.
It's our friends Sawyer who are testing it out. And so we're super down to give you guys some help. What's up, Jack? What's your question?
What game are we playing today?
We're playing Fortnite today. Fortnite.
Why not Warzone?
We can play Warzone later if you want. I'm cool. Let's see.
So you can play Fortnite and Warzone?
Well, let's see how many people want to play Fortnite. If there's only like one person playing Fortnite, I'll play Warzone with you. Is that cool?
Yeah.
Yes. Okay. Cool.
Can I be the first person?
Yes.
Hello.
Yes. I'll let you help. What's up, Ethan? All right.
Rigged.
Okay. Rigged. I know, but Jack is very rarely here. So let's help him out. Let's help out Jack. What do you want to learn about, Jack? You want to learn about fractions?
Yeah.
Okay. Cool. Do you know how to add fractions?
Yes.
Okay. So if I told you, for instance, to add, let's say, like 3/7. What's up, Infinite Bracelet Official? Good to see you on the TikTok. Plus,
Hey, guys.
if I asked you to add these two, do you know how to do that? You know how to do that, Jack?
Yes.
How do you do it?
No. Okay, so the top would be a 5.
Top would be a 5? What do you mean a 5?
Like a 5.
Oh, I see. You're just adding these two up together?
Yeah, right?
Yeah, so little trick here, Jack. When you're adding fractions, you need to make sure that these numbers on the bottom, the denominator, are the same. Okay? That's the only way you can add fractions together. So
Imagine the bottoms ain't the same.
good. If the bottoms aren't the same, we need to change them. All right? So for instance, if we had 1/3 plus 2/3, do you see how these have the same denominator, Jack? Do you see that?
Yes, because that would be third. That would be 3/3.
3/3. Yes. See, that's easy. If these have the same denominator, then you can add the tops.
One.
What's up? What's up, Teacup?
That would just be 1.
Yes, correct. 3/3 would just be 1. Yeah, you're very, very correct. So Jack, when they're different here, what we need to do is we need to change these denominators into something that's the same. Okay.
But how do you do that?
Good. So here's what I'm gonna do. So anytime you have a fraction, Jack, let's say for instance I had the fraction like 2/3. Okay. I can multiply this by whatever, as long as I multiply the top by the same number as I do on the bottom. Okay. So for instance, if I multiplied this by, I don't know, 4/4, this would be 8/12. And these two things are technically the same number, but this has a different denominator on it. Okay?
Okay.
The reason for that is this is the same thing as multiplying by 1 is what it is. So 4/4 is 1, so we're not changing the number. Okay. All right. So, what I need to do, Jack, is I need to find what's called the least common multiple, or the LCM. Have you heard that? Have you heard that term before?
We did that at school. And what's the other one? There's
GCF.
one more.
It's GCF
Yeah,
and LCM.
Yeah. And I forget it, so like I don't even know what it is.
Okay, well that's all right. So we can help you out here, dude, Jack. Okay, so the LCM is the lowest common multiple, is what they mean. Which means if I'm to let's say we have these two numbers here. Let's say we have 5 and 7, and I'm gonna do.
Oh, you can make a cross in the middle.
You could, yeah. So we can do multiples of them, right? So multiples of 5 would be 5, 10, 15, 20, 5, 30.
35, 40, 45,
Good.
50,
Let's stop.
50,
Let's stop at 35. Let's stop at 35.
60, 65, 7. Okay.
Okay, let's stop there. All right. Now, what are the multiples of 7?
7, 14, 21,
Good.
28,
14, 21.
32.
No, 35.
30, yeah, 35.
40.
42.
Good. Okay. Do you see how there's a number that's the same between these two?
Mm-hmm.
Which one is it?
35.
Good. Yes. So since that number is common between the two of them, that's what we're going to call the least common multiple. Okay?
Okay.
All right? So, one sec. My mic levels keep changing on this. Why? Okay.
Wow.
I don't know. Windows is a mess. Okay, anyways. All right. So this is the least common multiple is what we say. Okay?
Okay.
So what we're going to do is we're going to try to turn this number into having the same base on the bottom of 35, all right? What do I need to do to, like, make this one have a base of 35? What would I need to multiply the 7 by in order for it to become 35?
5.
5, good. So here's what I'm going to do, Jack. I'm going to multiply the top by 5, and I'm going to multiply the bottom by 5, okay?
Okay.
All right. What about this one, Jack? What am I going to do to turn this one into, again, what do we determine our least common multiple was, right?
35.
35, good. So what do I need to multiply this one by to get to 35?
7.
7. Good. So I can multiply the top and the bottom by 7. That's the key thing. You got to multiply both, okay?
Right.
All right. Okay. So let's see what we get here. What does this turn into? What is 5 times 3?
Oh, that's a 15.
Good. That's 15. Good. And then what's 5 times 7?
35.
Good. All right. So that's 15 over 35. And then what does this become? What's 2 times 7?
Top will be 17 and the bottom will be 35.
No, 2 times 7 is going to be 14. 14.
Yeah, I meant that.
14. Good. Okay. All over 35. Do you see how these now have the same denominator? See, they got the same number on the bottom? Okay. Now we can add them together. That's okay. Now we can add them. All right? So what are we going to get?
The top
Yeah.
would be 29.
Very good. And then what's on the
After that, 35.
over 35. There you go. Nice job, Jack. You did it. Isn't that cool, Jack? You know a little bit more about fractions now? Awesome, dude. Let's get you a bomb.
Yo, what's
Yo,
up?
what's up, Ramiro? Ramiro, dude, how you doing, man? It's been a minute.
Good. In a minute. Yeah.
Are you enjoying the 3-day weekend, man?
Nah, I'm at work.
Hopefully no one's robbing you at work again, dude. Like, I saw that video of, like, someone trying to rob you at work, and I gotta say...
My brother's fucked up for that.
No, I appreciated it, dude, because I was like, damn, dude, Ramiro's a G, dude.
That's
like,
dope.
Some person, like, tried to, like, rob you, and you chased after them, too. You were like, no.
You're like, fuck nah, bitch.
Yeah, damn. You're the only person working in that store? Like, you're by yourself?
Yeah.
Wow.
I open and close.
Wow, that's crazy, dude. Yeah. Well, I mean, stay safe out there, man. I don't want you to get, like, hurt and stuff. But, yeah, a lot of crazy people, right?
Yeah. You got no idea.
Dude, I bet you deal with, like, some fucking nutsos out there, dude. They should give you a security person at least or something. Like, you are security, I guess.
Practically.
But that's a lot, dude. Cause like you're still a kid. Like you shouldn't have to be security.
Yeah, I'll be fine.
Yeah, he says I'll be
I'm
fine.
Mexican.
I'm Mexican. He's like, I got it. All right, nice, dude.
That's the excuse. That's the excuse I used at the party I was at when
Yeah.
I was drinking,
Yeah.
and they were
What'd
like,
you say?
"Bro," I was like, "I'll be fine. I'm
I'm
Mexican."
fine. I'm Mexican. I can deal with it, right? Damn.
Yeah, like it's normal.
It's normal. It's normal, he says. All right. Everything else going well with school, Ramiro, too? Yeah?
Yeah, I finished school. I got all 80s and 270s.
Okay. All B's is all right. Yeah, a couple C's. It's okay. You're still passing at least. That's good, right?
Yeah,
Nice.
yeah, it was from some time that I missed in school. That lowered my grades for those two classes. It fucked me
Yeah.
up.
Yeah, no.
That
It's
class-
hard. It's hard to come back from stuff once you start like missing class. I know that for
Yeah,
sure.
like especially when it comes to like science and math shit. So it was
Yeah.
for algebra 2 and physics. I missed a couple weeks because of some shit that happened
Okay.
and fucked me up entirely.
Oh no. Well, if you ever need help to like get back on your feet with the math stuff, like we got you
Yeah,
here. I can
well, I
always help
got
you out.
back on it.
Okay.
In the end, I just needed 2 more points for an 80 for math, but there were no more retakes I could take, no more like extra credit work I could take, so I got stuck with a 78.
Okay. Well, that's close. I mean, that's almost an A. That's almost a B. It's like a B
Yeah,
minus.
yeah. There was no more extra credit assignments, so I couldn't do shit anymore, raise my grade,
That's okay.
and that fucked me up. But oh well, there was nothing I could do about it.
Dude,
That
there's
was
always next year. There's always next year. And next year you
yeah,
hopefully won't have to miss any class, right?
yeah, hopefully, because next is my last year.
Oh, damn, dude. About to be a senior, right?
Uh,
Wow, dude. You guys grow up so fast, dude. That's cool, man.
I know, right? It'd be like that. I'd be looking at kids I used to babysit at church,
Mm-hmm.
and they're all in high school. Most of them are in high school,
I know, dude.
and I'm
Like,
like,
everyone grows
"Fuck."
up. And, like, you blink before your eye, and then you're like, oh, now I'm an adult. Now I gotta, like, pay for things. Like,
Shit.
health insurance.
Nah, but I know there's a whole new shit here in the office hours. Haven't been here in a while.
Yeah, no, it's cool. You're always welcome back, Ramiro, dude. Always, dude. Anytime you got like you need help with like questions and shit, dude. Also, like we always got you. I always just like to talk to you guys too. It's always fun.
Yeah, I like talking to you guys too.
That's cool, dude. Nice.
I, I love how this server's growing.
It is, dude.
Yeah.
Yeah, it's getting bigger and bigger, dude. Yeah, it's cool. You've been here since like almost the very beginning of it, right? Yeah.
Yeah, I've been here for like I think a year and a half now.
Okay.
I joined in like 2 months after my brother.
Yeah, he got you in there. Yeah. That's super cool, dude. All right, good to hear from you, Ramiro. Let me help out a kid here real quick, with questions. But yeah, it's always good to hear from you, man. All right, what's up, Teacup? Where you at, dude? Wait, Teacup, why is your mic like so quiet? I can barely hear you, dog.
Hello, yes, I'm the Ghost Quick Future. How are you today?
There we go. What's up? We have someone in the TikTok asking, can you explain relations and functions? And I said, like, what type of functions and relations? Maybe give me an example.
Okay,
Example question. Yeah, if anyone ever gives, I should put that on like the instructions on the TikTok and like in big
Give an
text.
example.
Be like, please give an example of what you need help with, and then I can figure out what you need help with. Like this is a great example of posting an example of what you need help with. What's up, Riplaw? So this is science, I guess, right? Why is water known as the universal solvent? It's kind of cool.
Yes.
Do you know what the difference between like a solvent and a solute and a solution is?
A solute is something that gets dissolved.
Good.
A solvent is the thing that does dissolving. And then what was the other one?
Solution.
Solution, that's the after.
Well, so the solution is the solute plus the solvent is what we say.
Yeah,
Okay.
that's the after.
Yeah. So solvent is. You're right. This is usually a liquid that does the dissolve. This is usually like usually a solid.
Usually it's acid.
Usually it's acid. It's always acid. Yeah. Usually a solid. Good. And then this is the liquid that does the dissolving. Yeah. It's actually kind of cool. Solvents and stuff are, this is kind of a cool topic.
I'm
And
and
then-
my science, that's what I'm going to say.
Is this what they call like integrated science class, like ISP or something? It's like chemistry, biology, and physics all in like one intro class or something?
Yeah, that's pretty much what it is, but it's
Yeah.
called something different.
Yeah, that's pretty. Oh, we got Halo theme. Is Master Chief coming in? What's up, Tony? All right.
This is the released questions that were like on the final, and they made a new one, so it's probably gonna be 200 times harder.
No, it's not gonna be that bad. Okay.
It goes over all 3 years of science I've had.
So they say water is a universal solvent. Yeah, because it generally does dissolve a lot of things. It dissolves only solid substances? No, this is wrong, dude. What?
Water only dissolves solid substances, obviously.
It doesn't dissolve all known substances. That's also wrong.
I don't know. Maybe it does. I think it definitely dissolves diamond.
You know, there's you know, we can kind of think of something it doesn't dissolve, right? What about oil?
Diamond.
Oil. It doesn't dissolve
Ruby.
oil, right?
Maybe it does.
Well, that's why, for instance, like oil floats on the top of oceans and stuff. It's because oil, it doesn't dissolve oil.
Because oil's just worse. So
Well,
oil is lighter than water.
Yeah, I forget the exact reason why it doesn't dissolve. I think it has to do something with the polarity of it. Anyways, yeah, so it doesn't dissolve everything. It dissolves the greatest number of substances. I mean, maybe. And I don't think it dissolves things faster than all of this, because there's some really, you're right. Acid is a pretty good solvent.
Piranha solution, though.
Yeah, it'll dissolve a lot of stuff. Or like bleach. Bleach is a very good solvent.
I'm pretty sure piranha solution is the better solvent.
Yeah, piranha solution. Riplaw says, I don't know what the Halo theme is. Oh, the Halo theme is Master Chief.
You don't know what the Halo theme is? No, I'm done. I'm
I'm done. Yeah, okay.
How long have I been here? Let's see how long I was here and how
Yeah.
the day I leave.
Yeah. Okay, cool. Yeah, so I think it's answer C. Is that right? Did we know
Oh,
that?
hey, Gold.
What's up, dude?
On Wednesday, it was my anniversary, 1 year anniversary on the
Oh
server.
wow, 1 year anniversary. That's dope.
I was last week.
Last week, you've been here for a whole year.
Yep.
Wow, that's super cool. How long have I been here?
Probably a few years.
I've been here a couple of years. Oh, we're at
It's been 2 years for you.
I think it has been 3 years. I started this in 2020. No, 2021. No, I started this in 2021, I think.
I can check.
Yeah. I think the server
probably
started in 2021. So it's been like 2 years. Almost 3. I need a couple more for it to be 3. Actually, a lot more months.
You made it in. Let's see. You made it 2/25/2021.
Uh-huh. Yeah, there you go. Yeah, 2021. Yeah, that's when it was. Yeah. All right, nice. Okay, cool. All right, let's get you a point for that. That's all. Did you do anything special for the weekend, Teacup? Did you do anything fun?
Me, no.
No.
I'm off today.
Oh, yeah. No one has school today, right? I'm just teaching, so no one has school, but we're still here helping people,
Oh, so I'm not gonna be here on Friday.
Oh, okay.
Well, I
Why
might
is
be,
that?
I might not be.
Where are you going?
My school is taking us on a field trip to the theme park.
That's dope.
A theme park, bro? Like
Yeah.
when I was in school, like we took field trips to like museums. You're going to a theme park?
We're going to Busch Gardens.
Oh, okay. Is that like ghetto Disneyland?
Yeah, it's off-brand Disneyland.
Off-brand Disneyland? That's kind of cool.
Well, no, it's off-brand Six Flags.
Oh, off-brand Six Flags. Okay. I've only been to Six Flags like once.
Yeah,
Meg
actually,
says
look
school
up
ends
Busch
in 10
Gardens.
days,
It's
yeah.
actually pretty cool.
Yeah. Okay. Let's check it out. I'm always down to check
Look at
stuff
the ones
out.
in Williamsburg, not the one.
Is it like Busch Gardens like the beer? Busch Gardens like Busch beer? No. Okay. Oh, it's this is cool.
Prefer not use the one in Williamsburg, not the one in.
Not the one in Tampa. Oh, there's one in Virginia. Oh, I thought it was in Florida. What's up, Ramton?
There's two.
Not much.
It's a holiday today in the United States. Is it a holiday for you guys? For you Canadians?
Yeah.
I don't think so.
Canadians probably.
But
Not.
today in US? No, it's not holiday here.
It's not a holiday in Canada, right? Yeah, it's a holiday here in the U.S. Yeah. Oh, I see. Okay, cool. This is Ramton. Teacup's going on a field trip this Friday, but they're taking him to a theme park, which I was like,
Yeah,
what?
I heard.
Like, what? You get to go to theme parks? Where did you ever go
Yeah.
on when you were
We're
in
going to
high
the
school or middle school, Ramton? Where did your field trips go? Or did you even have field trips?
I don't think our school did a field trip at all for university or for high school.
Mm-hmm.
We one time took like a semi field trip. It was like a daily trip. We went to a tea company
A tea
or the
company.
tea factory.
Oh wow, Teacup would love that, dude.
Hey!
Yeah, Teacup would love that.
Yeah,
I gotta go there.
Yeah.
and it was actually the Lipton tea.
Dang, I'm drinking that right now.
He's drinking the Lipton tea, dude.
Yeah, and
I
it
have-
was kind of cool because we like learned how they make the tea from like the
Ah.
beginning till
yeah.
the end. But that was the only thing that I went to in high school. Maybe like one other thing, but I don't remember. For middle school, there was like an optional thing that they took us to like a trip to like a different city. And it
Oh,
was
okay. Like Ottawa or something?
No, it was in Iran. So
Oh, that's right. Yeah, sorry. You came into Canada when you were in high school, I think, right?
university.
University. Okay, that's right.
Yeah.
Oh, good. I might get off. I have something to do.
Oh, okay, Tico.
And then yeah,
It's
that
good to
one
see
was
you.
fun as well.
Enjoy the holidays.
Next
Tico.
year, if I join band, we go to Disney World.
Yeah, that's cool. Yeah, my orchestra did that in high school. You
It seems like
play
every orchestra does that.
Yeah, you play at Disney World or something, or Disney World. Yeah.
It's Disney World, yeah.
Yeah. But it was expensive. I remember my parents were like, "Yeah, we're not paying
It's
for
like
that."
$600.
Yeah, I was like, my parents like, "We're not paying for that."
Yeah, everything's included.
They're like, what are you talking about? We have Disney World at home.
In Disney World at home.
I love that meme where it's like, we already have that at home. We don't have to buy that.
We have KFC at home. KFC at home.
Yeah, exactly. That's what it is.
Well,
All right.
have a good day. Good
You
luck.
too.
Probably be back.
Thanks, man, dude. Yeah, come around if you want. You're good.
Oh yeah, the answer was it dissolved the greatest.
Was that that was right?
Yeah.
Had the right answer? Okay, cool.
Yep.
Love it.
Have a
dude.
good day.
You too, man. Okay, cool. Where's Habib? Habib's got a question. The blurriest of all screenshots where he said, I need to do something. I'll be right back. Just do my question when I return. Are you back? Is Habib back? Let's see if he's back. He's not back, I don't know. Habib, you back? Yeah, I didn't know how many people would actually need questions because today is technically a holiday. Some people were like, "Oh, are you even gonna stream today?" And I was like, "Yeah, I'll do it." I kind of in the U.S. at least, like when we have a 3-day weekend, Monday's usually like a barbecue or like recovery day, so you don't really want to go out. You don't really want to go out and party on. Everyone parties on Sunday, because then they use Monday as like their day to like come back to life.
That makes sense.
Yeah. Right. Yeah. I kind of did it on Saturday, so like Sunday was Saturday. I what was it? I DJ'd a boxing gym for 4 hours in the morning. It was one of my more interesting gigs. Yeah. And then I drove 2 hours to do another gig at some rooftop party, and then I came home and went out to a club, and then Sunday I was like, I need to sleep all day. Yeah. Let's see. Where's Noise, dude? I've missed Noise. I haven't seen Noise in a couple days. Hope he's okay. Always check up on people. Let's see. Maybe we got another question in the screenshots here. Oh yeah. Here, Ramton, we tried to do this one last time. This was like Ethan's question, and the solution for it was actually kind of weird. I'm just curious if you have any intuition on how to do this one. Because I saw the solution for it, and I was just like, kind of like, nah. And then Ethan's like, oh man, I gave you a hard one. Do we need Ramton for this one? And I was like, well, maybe, but it's not that these are hard. They're just very tricky because geometry tends to be like all these tricky rules that I don't remember all of them.
All right, so it says the diagram shows a hexagon all the interior, and the length of some of the sides are indicated.
Mm-hmm.
Okay, and then what is the area of the hexagon? Ooh, this is a
right. I looked at this. I was like, uh-oh.
Yeah, sorry again for this.
No, don't be
This
sorry, Ethan. It's just I'm just curious.
And do you remember the answer, Dr. Gold?
I don't remember the answer, but it's okay. I know you sent me the screenshot of it. No, yeah, I want to see if Ramton has any intuition on how to do on his ideas on how you would do this one.
okay. Wait,
Let's be on this.
so I'm trying to figure out if there is a way to figure out the top side, because they are 120 degrees.
Right.
This means that so when we go from each side to its opposing, there's going to be like 120, 120, 120. So opposite sides are parallel. So that's one piece of information that could be helpful.
Used. Yeah.
Yeah. And then because they are parallel, let's see if there is a way. I mean, if there was, I mean, there is this formula with like which is the I don't know what it's called, but I call it the um better version of the Pythagoras theorem,
Mm-hmm.
where it's like or c squared is a squared plus b squared minus 2ab cos theta.
Okay.
So something like that.
Okay,
So
what's my camera?
because I think once we have the other side, then it's easy to do this, because all you can do is just break it down into a bunch of triangles, and then you'll have the answer.
Okay.
But I want to figure out what's the best way of breaking this down into like maybe triangles, so that um so that we can figure out the interesting. Yeah, I think I would break this down into triangles, and then because we have two sides
Mm-hmm.
and we have the angle between them, then we can always find the area, and we can find the opposing side to it.
Okay.
So the area is just going to be the two sides times the sine of the angle, so sine 120. The only thing is, like, it's just the way you would construct the triangles, you have to be careful, because then it's going to mess up the entire uh problem if we want to.
So are you like
Actually,
are you trying to like break it up into like this is a triangle or something, and then like this is a triangle?
yeah, I think I figured out a way of breaking this into triangles. Yeah. So I think right now I'll come up on the screen so I can say what I
Yeah, yeah, yeah.
remember into like the triangles. I think the part that I'm trying to figure out is where where's there the part that I'm trying to figure out is how to find the the side that is on top.
Okay.
Because once we do that, we can finding the area of this is not easy but long still. Oh wait, this is not plugged in. One sec. All right. Yeah, so let's say we know this side. I think
Mm-hmm.
there's an easy way of figuring that out. Maybe I feel like there's an easy way of figuring it out. But actually maybe I can construct. But let's say we have this side. Let's say it's like 7 or something, right? Okay. Then it's going to be easy to figure out the area, because we can break it down into this, this, and this triangle. Because we know this is 120, this is also
120, right?
20, and the other one is also 20. So the area of this is going to be the area of each triangle. So the area of if we have like a triangle like this is A, this is B, this is theta. The area is AB sine theta. Then we can also find the opposing ones, because if we have like A, B, theta, C, then we have C squared is equals to A squared plus B squared minus 2AB cos theta.
Right. Yeah, law of cosines.
We can find the opposing ones.
Mm-hmm.
Then there is also another formula where you can find the area by like, it's like the sum of like S times S minus A times S minus B times S minus C. where S is just half of the perimeter. So since you can find those sides as well, you can also find this triangle.
Okay.
The question is, what is this length? Like, how can we find that length? I think that's the part that I'm trying to think about. I think one way of like maybe if we construct like some kind of like a right triangle like this,
Mm-hmm.
and a right triangle like this, and then like this, and like this.
Oh, and you
And we
make
have a
a square and
rectangle.
then subtract.
Yeah, we can have a rectangle. Since that's 120, this is 60. We have 4. Actually, yeah, we can find this. So this side would be 4 sine 60. Yeah, 4 sine 60. Then this side
It
is
would be
also
4 cosine
60.
60, right? This would be 4 cosine 60.
Oh, sorry. Yeah, my bad. Cos 60. This one would be 3 cos 60.
Yeah.
We can call it, let's call this side X.
Mm-hmm.
And then, yeah, similarly, this side would be 2 cos 60.
Uh-huh.
This side would be
1
1
cosine 60.
60. So we have 1 cos 60 plus 2 cos 60
Plus
plus
8.
8 equals to,
I like this.
I guess, 7 cos 60. I don't know
Yeah.
why I didn't get these two up.
That's okay.
3 cos 60.
3 cos 60, yeah.
Yeah, and then we get oh, sorry. Wait, was it doing the right?
7
sorry,
cos
this is
60,
7
right,
cos
plus
60
X.
plus X, yeah.
Yeah.
And then so X would be 8 minus 4 cos 60 degrees.
Okay.
Yeah, now that we have X, we can use,
So that's just 6 then, right?
sorry?
Isn't that just 6? Because cosine of 60
Yeah.
is going to be
Cos
just a half?
60 is 1, cos 60 is the bigger one. Yeah, it's 1/2.
Uh-huh.
So it's 2, so yeah, X is 6.
Oh, very cool.
Okay. Then your solution is gonna be like a bunch of these. So you're gonna have for
Could we do the whole rectangle and then just subtract
and
out
then
the triangles?
subtract. Yeah, I guess
I feel like
now
that would
that
be easier, right?
Yeah, that's actually much better. Yeah, so it would be 2 times 8 plus cos 8 plus 3 cos 60. Yeah.
Mm-hmm.
Which is 3 cos 60 is 1/2. So 9.5.
Mm-hmm. And then where's the 2 coming from? Oh, okay. Wait.
Wait, yeah, there's no 2.
There's no 2.
Where am I
Yeah.
going?
We don't know the height of this yet. I mean, we could get the height of it.
So, yeah, so it's 9.5 times
3 sine of 60 plus 2 sine of 60? Does that make sense?
so 5 sine of 60.
Okay, cool. Oh, and that makes sense here because this is also 5 sine of 60. Ah.
Yeah,
Okay, good.
exactly.
All right, we're consistent.
And then that's 3 over 2.
Uh-huh.
So that's going to give us, let's just write this as 19 over 2.
Oh, I see. Yeah.
And then we get 19 times 5. That's 95.
Yeah, 95 over 4, right?
Yeah, 95 root 3 over 4.
4, yeah. Okay,
And
that's
then we
the
have
total
to
area.
subtract. So this one was 4 sine 60, which we said is going to be 2. So it's going to be 2 times
4 square root of 3 over 2?
Yeah, sorry. Yeah, you're right. 4 square root of 3 over 2
Divided by 2.
plus, oh yeah, divided by 2 because it's a right.
Mm-hmm.
Plus the 1, or no, that one's gonna be 1. Oh god, this is, why is this? So yeah, then
They're all gonna be square root of 3 over 2, right? Because we're always doing some base, right? Times
yeah, exactly.
times
So
the
it
other
would
one, yeah.
be the square root of 3 over 2 then a 1/2, and then another 1/2 for the triangle,
Mm-hmm.
and then plus, and then we come here. This is gonna be, I guess, 3/3 square root of 2, and then another 3 as well. So it's gonna be over 8.
Uh-huh.
Am I doing this correctly?
Are you doing this one? Is that what you're doing? You're doing this triangle?
Yeah. So that's there's a 1/2 that comes
Right. So it's
from
from the 1/2
the
base times height,
triangle.
and then there's the 1/2 from the cosine 60. So that's 3 over
'Cause it's
4.
3 sine 60, 3 cos
Yeah.
60
You're right. Yeah, it's 3 square root
over
of 3 over.
2.
Yeah, it's
So
3
this
square root
is
of 3 over 8.
9 square root of 3 over 8.
Oh yeah, sorry, 9. Yeah, 9 square root of 3 over 8.
Yeah, and then plus. Wait, so how did we get to the other one? Was, I just want to make sure that it's 4 times square root of 3 over 2 times 4 over 2, yeah, which is 2, and then another 1/2.
Yeah.
And then plus the other one,
Mm-hmm.
which is 4 times square root of 3 over 8.
Mm-hmm.
Okay, now that we add all this up, so this 2 square root of, so we have 2 square root of 3
Mhm.
plus square root of 3 over 8 plus 9 square root of 3 over 8
Uh-huh.
plus square root of 3 over 2.
So I think we just want to make square root of 8, the over 8 our
And
common
then-
denominator.
Yeah, we take common, so that's going to be 16 plus 1 plus 9
plus 4.
plus 4
Uh-huh.
square root of 3.
Uh-huh.
This is going to give us 5, 14,
30,
yeah,
right?
14,
Is that
30,
30?
yeah,
30?
exactly. 30 square root of 3 over 8.
Uh-huh.
And then, yeah, I guess all of this would have been, yeah, thank God I didn't do this one.
Yeah.
We could have, but yeah, it would have been insane.
Yeah.
And then finally, it's gonna be 95 over 4. So let's
So
just
190
double
over
that.
8, right?
190 square root of 3 over 8
Uh-huh.
minus 30 square root of 3 over 8,
Yes.
which is 160 square root of 3 over 8.
Yes, okay, cool. We're getting closer.
So is it 8?
Yeah, is it 8? Ethan, was the answer 20 square root of 3? Where is he? Oh, I know he posted here in office hours at one point. Let me find it. Where was it? Oh god. There was
Imagine if I dropped a 2 somewhere. And it's like,
Yeah, one sec, let me find it.
no, it's
I know
21.
he posted it. He posted it earlier. Where was it? Okay. Yes, 20 square root of 3, dude. Yes.
Okay. Nice.
I like that, dude. That was cool. So here, if you want to see
Yeah.
what the official solution is, it's actually interesting. I was a little confused how they got to this. I liked your method of making a rectangle. That to me was more elegant.
Yeah,
and
I
more
think
intuitive.
the part to realize that it's gonna be like a actual.
So look what they did. They
oh,
said
it-
it's an equilateral triangle, and I was like, how the hell did they get that?
I feel like that just makes. Yeah, I guess. I mean, yeah, I wouldn't see.
I guess with the
triangle.
120, it's probably the 120, right? Because everything's 120, then you must have 60s on the outside, which makes it equilateral.
Yeah,
triangle.
I guess. Yeah, I think the rectangle, like whenever I say a hexagon,
Uh-huh.
it feels like because of the symmetries on the opposite side, it would be easier to make a rectangle rather
Right.
than it would be a triangle that has ends cut off. But I guess this is also another way. Yeah.
Yeah, they do a little bit less math, I guess, is what they do. But and then they have this one half AB sign. Yeah, this is what we were doing anyways with
Yeah, that's the. I think not knowing that is gonna definitely put a dent.
Yeah, a dent in it. Yeah. But yeah, no, that's cool. So yeah, Ethan, yeah, we did it. We got the same answer, but we did it a different way. This is actually a cool thing in math. It's there's not always just one way to solve a problem. You can do it a couple different ways. there was a lot of algebra in this one too, like right? There was not a lot of algebra, there was a lot of like keeping track of all the numbers, which I'm surprised we didn't drop a factor of 2 somewhere. Man, that was a cool one. Nice. Ethan, do you have another question for us? Since we did that one yesterday technically. Do you have another like fun challenge question? Where's Habib? I have Habib's question too we wanted to do, which I think was like it was probability with like Mississippi or something. This one was very easy. Also, anyone in the Twitch, if you guys have any other questions with math or science, like please, just drop you can either join our Discord, post a screenshot, or you can say something in the chat. If you just have like a general topic, I think someone earlier asked about just functions, and I was like, okay, well, what do you want to know about functions? Because that can go very deep or very shallow, depending what level of math you're in. All right, let's see. What's up, Habib? You're here? You're here? Nice, dude. Cool. Oh, it's okay. I'm glad you're here, Habib. I'm glad you made it. That's the important thing. Okay. Let's see. This was your question. It was very blurry. I had to... I feel as if I need to have... There's this one... I forget. It's like a crime drama or something where they're always like zoom enhance, zoom enhance, zoom enhance. I feel like that's what I need for this. I need to like zoom enhance. You can't hear me? Oh no. Why can't you hear me? That's a good question. Well, let's fix that. What do you mean? Wait, can anybody else hear me? I feel like people can. Let me check my audio. Test. Yeah, it's okay. Audio should be fine. Yeah, Habib says I can. All right, Ethan, must be something wrong with your side. It's okay. All right, the letters that spell Mississippi. Mississippi is such a weird word. Was it Mississippi? Okay. Are each written on separate tiles laying face down on a table. A tile is selected at random. The letters recorded, and then the tile is placed face down on the table. The process repeats. What is the theoretical probability of choosing a tile with the letter P? Okay. This is a good one. This is a probability. It's a pretty basic probability, Habib. But do you have an idea of how to do this one? Let's see. Where'd he go? Or Ethan must be reconnecting. Yes. Is it 2 divided by the total? Correct. Yeah, so in probability, this is actually kind of a good thing. So probability is almost always a fraction, and it's the number of I forget the exact term for this. It's the number of like occurrences that we would call like a success divided by the number of total possible outcomes. This is kind of the... Oh, there's Noise! What's up, Noise? Nice, dude. Yeah. Noise, is it a holiday over there for you guys? Do you guys have a holiday on Monday? I would imagine if Canada's not doing that, then I don't think England is either. But yeah, so what we're looking for is the probability that we're choosing a letter P, okay? There are 2 letters within this whole Mississippi thing. What's up, Teacup? That have the letter P. So, right, that's the total number of occurrences that would be called a success. And then, right, the total possible outcomes is the total number of letters in Mississippi, which is a lot. I'm going to assume it's 11 because that's the number I see for all the answer choices, but we can count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, that's 11. Okay, cool. So, yeah, the probability would be 2 over 11. That's right. Now, Habib, what if I made this a little trickier? Here, let me make this a little bit trickier. Like, what is... Trickier? Oh, how? Oh, I can make this all sorts of trickier. What's the probability of choosing a letter P and then a letter I. What would that be? Do you know how to do that? This is called, I think, like joint probability is what it's called. It's like the probability of something happening and then something else also happening afterwards. He says 2 over 11 times 3 over 11. Close. Close. Well, actually, yes, because I did say that. The thing does say that the letter's placed right back down. Yeah, correct. Yeah. So, right. Whenever you have to have two events happen after each other, you multiply the probabilities together. So in this case, this is right. 2 over 11 is the probability for the P. I has 3 different I's in it, so that's times 3 over 11. But to be careful here, a lot of times in questions like this, they'll say that you're not going to put back the letter that you picked up. We call this without replacement is what happens when for instance, the big fancy one is like if you have a deck of cards and you take, what's the probability of like drawing an ace and then drawing a 2 or something? So what would that be? Right, good. So if we did not replace the letter that we pulled out, then this probability here for the I wouldn't be 3 over 11. It would be 3 over 10. Because now you only have 10 letters that are left to pick from. That's where that comes from. Yeah. So, yeah, be careful. In this question, the word problem said that, yeah, it makes sense. Yeah. In this one, we said that the tile was placed back, was put back on the table, so the total number of letters doesn't change. But a lot of times we do things without replacement, and then you have to remember that. Yeah, cool. All right, good. Nice question, Deeb. I like that. Probability is cool. There's a lot of fun ones with probability with, what's it with, like, the choose functions, like NCR, NPR? You can do a lot of fun ones with that. There's a lot of interesting questions. For instance, like, how many different ways can we arrange, like, people at a table? That's a cool one. Nice. Okay, cool. All right. Got 12 minutes left. Let's see what we got. I think Noise had a question last time that I didn't have time to go through. I kind of wanted to do it. Where's his question from last time? Find the general solution rating. Did you do this one with him, Rampton? Did you do this one? The 3 cosine and the 2i sine?
Which one?
This one right here. Did you do this one with him?
Yeah, I did that.
Oh, okay, cool.
Yeah, I think I sent it to him or I put it in the comment chat.
I think you did. Yeah, I think I saw you in
Yeah.
the chat. This is a cool one. Find the general solution.
You should have the solution somewhere though. If you want me, actually, wait. Let me.
Well, there's Noise. Noise says, "Oh wow, what's up, Noise? Oh wow." Do you have another question, Noise, or do you want us to live run through this one? Because I would learn something going through this anyways.
I have the solution. I can post it, or you can give it a try. See.
Yeah, Noise says, yeah, have a go. Noise says, have a go at it. Okay.
Because Noise did it differently than I did.
Oh, okay. Well, let's see how I would try to do it. Let's all struggle. You know.
It was interesting because his way looked harder than mine. Because he like did like a kind of like a tricky thing.
Okay.
But like for me, it was like more straightforward. But then you kind of have to like see something to be able to do it. I don't know.
I like yeah the magic in seeing things. Okay. All right. This is weird because we have x in 2 different trig functions, which I think I want these to be the same trig function. X equals pi. Wait, does that work actually? I mean, that's probably one of the solutions. X equals pi is a solution, actually. That's kind of cool. How did you find that, Bob? Did you just look at that? That's cool if you got that. Okay.
Wow.
Would I just convert this to like e to the pi I? Is that how you did it, Rampton?
Sorry?
Did you convert this to, for instance, e to the, what is it? Not e to the pi I, but you know,
E to the pi.
e to the ix.
I feel no, I didn't do it, but that was actually something that I thought about. I think it might work, honestly.
Yeah, let's try it. I'm curious. I always forget what the sine definition.
I think sine is e to the pi I, or ix minus.
Yeah, it's these here. I got them. It's e to the I, but yeah, one of them has an I on the bottom. I remember. There we go. Let's copy that. This is kind of you can brute force a lot of the trig identities using this definition. And if you remember how to multiply exponents together, that's one way to do it. Bob, if you're ever wondering. Yeah, it's a cool little trick. Okay. So I can call this 3 times e to the ix minus e to the negative ix all over 2I. I'm going to say plus e to the ix plus e to the negative ix over 2. And then I'm going to say minus or plus 1 is equal to 0. Okay. I think I'd like for these to be the same denominator. So I'm going to multiply this whole thing by I over I guess. Right? So that's going to get me 3 e to the ix minus 3 e to the minus ix plus I e to the ix plus I e to the minus x all over 2I. Plus 1 is equal to 0. Okay. And now I'm solving for x. Okay. Okay. All right. I got 3 plus I e to the ix. And then it's plus, what is that? I minus 3 e to the negative ix. Okay. No. Minus 3 minus I e to the, oh, I forgot the I here. E to the negative ix all over 2I plus 1 equals 0. Okay. Okay.
I probably wouldn't do it that way.
Noise says I wouldn't do it this way. Thank you, Noise. Thank you for letting me know, dude. This doesn't work. Does it not work this way?
Well, I haven't tried doing it that way.
Yeah, I think I'm trying, but I
don't
think
know.
I'm failing here, dude. This is not working. Okay, all right. Here, you. All right, let's scrap. This is a bad idea. You know, this is like a dead end. I was hoping something pretty would come out, and then I could.
Yeah, I thought about this as well, but then I was like, I feel like I don't want to deal with that many.
Yeah, Noise is smarter than gold. No, yeah. Again, I'm not the smartest person. Like, I'll full blown always admit that I'm not the smartest person, but I'm one of the better people at teaching. So that's what counts to me, at least. Yeah. Okay, Noise. Here, give me a hint. Give me a hint. How do I start this one?
Let Ramit show you his way first.
Oh, okay. Okay.
Do you
Ramton,
want me to just? Yeah. So
what would be a hint? I like the.
Yeah,
I
what
could
I-
just look at the solution, get the answer, but I'd like to kind of figure it out.
yeah. So what I did with this one is like, kind of, like whenever I see like sines and cosines by themselves,
Uh-huh.
I'm like, all right, I gotta somehow get some sine squared and cosine squared.
Correct.
Maybe I can get some ones out there. And so the observation, I mean, I kind of was like playing around just to see what happens at first. It's not like I immediately knew this is gonna give me something nice.
Uh-huh.
But I was like, okay, let's just take these stuff to the other side,
Okay.
where you can think about the sine, doesn't matter.
Sure. Okay. 3 sine
And
of
then
x.
so we get 3 sine x equals to like minus cos x
Right. Minus
minus
1.
1.
Okay.
And then I'll square both sides.
Ah, okay. I like this.
And then once I do this, I get 9 sine squared x
Yes.
equals to cos squared x
Uh-huh.
plus 1 plus 2 cos x.
Okay. And now I can switch this, right?
And then I was like, okay, now the thing is, because
This
I
is gonna be
know
a quadratic.
this is gonna be 1 minus sine squared x,
Uh-huh.
right? Okay. Then this means that the left-hand side can become minus sine squared x plus 2 cos x. And
Okay.
then this is 2 times 1 plus a cos x,
Uh-huh.
which I can extract from this top equation. This is minus 3 sine x.
Oh, that's so elegant.
And then so we can bring this to the other side. We get 10 sine squared x equals to what's it called? Minus 6 sine x, if I'm not mistaken. Yep. And then this comes to the other side. And then we cancel out like a 2 just so that. So we have 5 sine squared x plus 3 sine x equals to 0.
Uh-huh.
And then sine x, we'll factor it out. We get 5 sine x plus 3 equals to 0. And then we'll get sine x equals to 0 and sine x equals to negative 3 over 5. Which if we take the arc sines of both of this, because whatever, so arc sine of 0 is just 0. So this is going to give us x equals to 0, but then plus n pi, because every pi radians we can go back,
Uh-huh.
or we get the same exact sign when it's 0.
I see.
And then with this one, I'll check quickly on Wolfram. So arc sine of negative 3 over 5. This is negative.
Yeah, it's that 345 angle,
It's,
right?
yeah, it's negative
What is that? 36
36
degrees. Yeah, because the other one's 53.
Yeah, 36.87.
Uh-huh.
So x is negative 36.87. Let's just say approximately 37, just so that.
Sure.
Okay. And then the one thing is, because if we look at sine on the
Mm-hmm.
on this, if this angle has the sine negative 3 over 5, then this angle being 37, because this is negative 37, the fourth quadrant, this angle also has the sine negative 3 over 5. So then we do 180 plus 37 degrees, which is 217 degrees. And this is also, we can add 360 to this just so that it's between 0 to
0 and 2 pi.
0 and 2 pi. Yeah, and then this will be 360 minus 37, 323
Mm-hmm.
degrees. Yeah, and then we can add 2n pi this and 2n pi to this as well.
Okay, cool. All right, that's
Yeah.
that's it. Dude,
And
this
then
is pretty here. This here is pretty. Like,
Yeah, that
I wouldn't
one-
have realized that.
I think that one I was like, oh, okay, this comes out nicely.
That's the flair,
However,
dude.
Moist did actually point out something interesting as well. Because I ended up squaring both sides of this equation,
Sure.
I end up creating an extra solution that might not be necessarily the solution
Oh.
to this. So we'll have to plug back in like 3 different angles. So 0
Into here and just make sure they actually work.
Yeah, if we add in 0 actually, which was a solution to this. So 0 or pi should be a solution. Actually, sorry. This is 0 plus 2 pi n and pi plus 2n pi. So 2 of these. So if we plug in, so I got 4 set of solutions.
Right.
The first one, if we plug in 0, we see that it doesn't actually work.
Yeah. 0 doesn't actually work. Yeah. Okay.
So this one doesn't work. If we plug in pi, then it does work, and then plus 2n pi doesn't matter because that's just a 2n pi periodic. So this works. And then we can plug in 323 and 217 just to see whether those work as well or not. I'm gonna.
That's interesting that the squaring introduces new solutions. I forgot.
Yeah, because it makes sense because like this is a linear solution,
Sure.
or this is a linear equation.
Mm-hmm.
So I guess adding more to it than it would.
I would have just taken this at a quadratic, which I think probably would have gotten the same thing, right? I would have gotten 9 minus 9 cosine squared x equals cosine squared x plus 1 plus 2 cosine of x.
Yeah, so I plugged in 217 degrees,
Mm-hmm.
and it seems to not work as well. But then I'm gonna plug in what was the other one? 323. I'll just make sure it doesn't. Yeah, so 300 or 217 degrees actually doesn't work.
Mm-hmm.
But then if we do 323, is that the one? 323, yeah. Then yes, this works. So I've essentially introduced more solutions to this. So this one doesn't work. This one does.
Oh, this was ugly. too.
Actually,
I don't want that. No.
technically, one of these solutions it's because of actually the period
Okay.
rather than the square. But squaring does introduce an extra solution, which I think is still supposed to be the 0.
Right.
But it works out anyway. So this gives us 2 set of solutions to this.
Okay. This one. Very cool. I like that. That's cool. Very elegant. Nice.
I've logged on now. I can maybe
And
scroll
Noise did it
down.
with a Weiss-Strauss substitution, which I was
Oh
like,
my god, what is that noise, dude? What? You chill on that,
Okay, I'll do a bit of scribbling.
dude.
Right, let me move over somewhere over here. Right. Oh, I'm gonna spell it awfully wrong.
Okay.
I don't want to spell it.
I've seen Weiss-Strauss substitution be used in integrals mostly because you don't have any other way of doing it. But this was actually a cool one. I didn't know you could do it.
Right. Well, right, there we go. Weiss-Strauss. Substitution.
Oh, up here. Right.
Basically, you make a variable t, which is equal to tan half x. And we can write sine and cosine in terms of that. So sine is sine of x equals 2t over 1 plus t squared, I think.
Okay.
Yeah.
Let me double check that. Yeah. And then
I know the
cosine x is
Oh, these
the
are like
denominator
these are
is
some
always one
far out trig substitutions. Wow, I haven't seen these before.
right. So we have our original equation, 3 sine x plus. That is right, right?
Uh-huh.
We sub in we do our Weiss-Strauss substitution. We say we have 3 lots of 2t over 1 plus t squared plus 1 plus t squared. 1
Um,
Also,
minus t
just
squared
for,
plus 1 equals 0.
just also to add something to this as well, because it's kind of a cool thing.
Yeah.
When Noise is writing it down. So this equality only holds for for
is it for only for certain
no,
quadrants? For like quadrants 1 and 4?
no, it works for all of sine, but it only works when sine gives you a actual what's it called? Gives you a what's it called? What are the set of numbers? There's integers and then there is what did the set of
Rational?
cube called? Rationals, yes. It only gives you when no, not rational.
Real?
Things that can be written as fraction. Why did I forget this right now?
Rational. Rational is things that can be written as functions.
Rational is it?
Yeah.
Oh yeah, you're right. Rational and real is the other. Yeah, this only works for rational values of sine.
Okay.
And you can see, but like this is the idea of like dense and all these stuff comes into play as well, which is kind of gets a little tricky.
Mm-hmm.
It's like because if you think about sine x covers every number from 0 to 1,
Right.
but this doesn't.
Oh,
Because
tangent doesn't. Right. Okay.
this is only rational numbers.
Mm-hmm.
If it's I can solve for, or like I can get sine x, let's say for some reason, if I wanted to be pi over 4, which is a number between 0 to 1.
Right. But it's not rational.
This can't be pi over 4.
Right. Yeah, exactly.
So this works for very thing, and there's a thing called a projection. You can actually derive these like using basic geometry, which is also like a cool way. I don't know if Noise knows how to. Do you know how to derive these two things, Noise?
Probably not.
There's a thing called like a projective geometry. Like you like put like a point somewhere and then you draw a point. It's cool. Like I'll might go through it at some point. But yeah, there's the caveat to this that this only works for rationals and not reals, and that begs the question whether reals are just numbers that are computationally difficult, which is
Mm-hmm.
an area of discussion in math right now.
Oh wow. Okay. Okay. Wait. Let me
But
see.
yeah,
You multiply
but
through
this is
here
a
by.
this is a really cool solution. I really like this.
This was 6t plus 1 minus t squared plus 1 over t squared. Wait. How'd you get to here, Noise?
You just multiply through. I've made a mistake.
Uh.
I flipped the signs wrong on here. This should be 1 minus t squared.
Yeah.
Ah.
Right.
Okay. Okay. This is minus. This is plus.
I'll fix
Yeah.
it here.
Yeah.
But you get the gist.
I get it. Okay. Cool. All right. Good. All right. At first, I was
So
like, wait,
taking-
what? How's that happening?
The inverse tangent of both sides, you get half x equals n pi minus what's that? 0.322. This is in radians, by the way.
Got you.
And then you just multiply everything by 2. So you get x equals
Hello.
2 n pi minus
What's up, Hikaru?
0.644.
Can
Nice.
I say something?
Yeah. What's up, Hikaru? What's up? What do you want to say?
Okay, it's gonna be kind of weird.
Okay.
Did you know that cats can lick their own scars?
What? God damn it, Hikaru, dude. Oh man.
Did I just hear?
I don't know. We have some interesting children sometimes who come up and say things.
Okay.
Okay, very cool though. I like this. This is cool. This is I didn't know these identities before. So this is very cool. I learned something new today.
Yeah.
Thank you, Noise dude. I appreciate that too.
It's a pretty neat
That's
neat
pretty
solution,
neat.
to be fair, how it's all.
It's pretty. It's elegant. We like it, dude. Nice. All right, cool. Awesome. We learned some stuff today. Thank you everyone for coming to office hours. Had a great time. If you guys still have questions, please. Sawyer is running an AI math bot thing. You can always ask it questions over text using !AI. Oh, there you go. That'll send you the link for how to get to it. My brain hurts. Habib says, "Yeah, it's okay. It's all right. But it's good that you saw some of it while it was Habib. It's this is the part of math which becomes like a puzzle of just like moving things around. It's cool. It's like a puzzle. Cool. Okay. Our next stream is going to be Wednesday. That's going to be an hour later. So 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Please come by, ask any math, science questions you have, or like if you have something you don't know and you want to learn, and honestly, like I learned stuff here too. So I'm always happy to go through things that are far out there and a little bit more difficult because I get something out of it. It's very cool. Yeah. Let's see. Okay. All right, yeah, and as promised, I will play video games with you guys too. So, if anyone wants to play Fortnite with us, I'll do that on the actual gaming stream next.
Or if I got Fortnite updated.
Did you get Fortnite? Noise. I heard you were downloading it again. You said you were
Yeah,
downloading
I had it downloaded. I just need to see if it's.
Oh, see if it's
updated
updated. Yeah,
one.
no, I'm curious. I'd love to play with you at some point, dude. Yeah, because then we say
362 megabytes. That'll be done.
Okay, nice. Okay. Ethan says, I have other work to do. Okay, that's okay, man. All good. Well, Ethan did win the challenge last week, so I understand why he doesn't want to play now. It's funny how like motivation is such an important driver of things. When there's no longer a prize involved, they're just like, yeah, I don't want to do it anymore. I'm just like, yeah, I get it. It's how life works. But the important thing is realizing what the prize is, even though when it's not there. I think that's the hardest thing with education sometimes is people don't directly see that, doing well in classes and education is literally going to get you things later in life. It's not close enough for them to fully motivate them, I guess. What's up, Ripple? Yeah. Yeah. Cool. Let me get OBS working here. No, stop it. Remind me later. Let me do this. Okay, cool. Fortnite Monday. All right. Oh, Ramton, I was gonna ask you did applied math, right? Well, that was your degree.
Yeah, kind of. I guess it's like, I got a Bachelor of Science, but it's technically like more math than it was science, to be honest.
But you took a decent amount of math classes to
I took
almost basically have a math major, right?
Yeah, I took like that's the thing is like I'm not a double major, but like I took in more math than some of my friends who were math majors.
Mm-hmm.
I took 22 classes in math.
Wow.
And 23 in like physics.
I didn't even know that. I don't even they offered 22 different math classes.
Yeah, I took like pretty much my electives, and also I took some extra terms. That I just took math courses as all of my elective courses.
Yeah, because I have a student I'm actually working with. He's in high school and whatnot, and he wants to maybe do like applied math. And he asked me, he's like, well, what would I end up doing in college? And I was like, oh, well, I never went that far in math. I only got up to complex analysis.
Studying or like research wise.
I think maybe like research wise. And I said I think it would be a lot of like coding, like because he was asking like what should I do over the summer, because he has a whole summer free, and he's like, what should I do if I want to get involved with applied mathematics later in college? Okay. I told him maybe learn a coding language or something, right? Because I feel like in applied math there's a lot of simulation work, right?
Yeah, I mean it depends if you're going into math. I mean there's still like a huge part of it is like understanding like math and everything. Like once you pick up coding, it's actually like not that difficult I mean, I say that, but like I don't have like an extensive coding thing. Mm-hmm. But even to all of the friends or peers that I've had that they were coding, they were never saying coding is the hardest part of it, right?
Yeah, it's just like it's a basic skill you need to just like get your foot in the door.
Yeah, but I would say definitely coding is a good thing to pick up early on, because for me it was definitely some kind of hurdle that I needed to overcome. Mm-hmm. But yeah, I would say coding is something because you can learn it early,
right?
And you will gain more appreciation the more you learn math you learn. Mm-hmm. But that's for every other thing, because if you learn math as well, you will only gain appreciation once you understand more. So yeah,
I feel
would
like
say
I learned coding like early in my like 7th or 8th grade, but then I like relearned it again when I got into high school and I actually had to use it for something. And I was like, oh, okay. Here's like the actual reason we learn it. I feel like if you learn a
Yeah.
language just to learn a language, it doesn't really stick until you're like, oh, why am I learning this language?
Yeah, exactly.
Yeah.
Learning coding helped me with summations in maths because it kind of works the same.
Yeah, because it's all the same. Was it the same? Like workflows are kind of similar.
It's
Yeah.
it's sort of like a for loop, isn't it? Like
Yeah.
everything increments by once.
Especially when you get into like
That's-
recursion, like recursive things and
Yeah.
whatnot. Yeah. Super cool. Yeah, maybe I'll have the kid, because his mom's asked me. He's like, well, what do I, he's like, I could put him in tennis camp or something. I was just like, he's a very smart kid. So I'm like, maybe I'll tell him to learn a coding language. But then she was even like, or maybe you could like supervise him on like a project or something. And I was like, yeah, but like, I don't know where to start there, like in terms of applied math. Because she was asking like, yeah, what do they study as like math majors? I'm like, I don't really honestly know. I think it's a lot of simulation work.
I don't know if you want to refer him to me, but I can work with him a little bit for the math part as well.
Yeah.
But coding as well, for sure, I would say is like definitely a good thing because you can get it started early on,
Right.
and getting comfortable with that kind of sort of like stuff, it would definitely help out.
Yeah, it would definitely help. Yeah. And I know there's like a zillion like code academy or whatever like coding website things that you can just go through and it'll basically teach you how to code at this point.
Yeah, absolutely.
I use C++ for Dummies. I literally had like the book.
Yeah.
I literally read through like C++ for Dummies. That's how. Yeah, I remember going on road trips to California and I'm in the back of like a 15-passenger church van and the AC is not working and I'm sweating and I'm reading this C++ for Dummies book, learning how to learning what the fuck a pointer is. I was like, ew.
Yeah,
Stop.
pointers
are so gross.
Pointers are definitely. There is like a cool thing about pointers as well that I learned. I guess. If you want to head out, I can let you go. But like, there was something because, pointers are essentially like a bunch of things that tell you where the information is.
Right. You're assigning memory addresses almost.
Yeah, exactly.
Right.
And then like one of the cool things that I learned was when you delete stuff, like you're deleting the pointers. You're not deleting the
You're not deleting where the actual information is. And then so this is where like you can go back to it and recall it if you have to. Because then there's the heap and everything. Oh man, it just gets like it becomes like a.
Yeah, exactly. And then like I heard that people, like I guess a cool kind of side story is that the U.S. government, the CIA, pretty much dumped a bunch of hard drives in like somewhere nowhere in Africa.
Right.
And a bunch of like pirates or like I guess like criminals found these, and because they didn't like actually physically,
they didn't actually physically write the ones and zeros. They just like soft erased it. Yeah.
Yeah, they were actually able to extort the CIA for like millions of dollars.
Oh my god.
And CIA was like, yeah, we're paying this because like it was very sensitive.
Yeah, it's like national secrets. Wow, that's nuts.
Yeah.
Oh, that's crazy. Cool. All right, here. Let's see if anyone wants to play Fortnite with us. We'll be on. Noise, is yours downloaded yet? Did you want to come play with us?
Yeah, that's done.
All right,
I'm gonna head out also because I'm tutoring someone in a few minutes.
Okay, good to speak to you, Remton, dude. Anyone else
See you later, dude.
who wants to hang out? Come to the recess voice chat. It's down below. Yeah. Have a good day, Remton, dude. Okay, there we go. All right, and then let me end this, and then I probably got to add you, Noise, don't I?
Yeah, I DM'd you.
Yeah, nice. Okay, cool. Let me add you. Where is add my friend? Wow, we're gonna play with someone all the way from England, dude. That's so cool, dude. I'm gonna add you as my friend. Am I on NA East? Yeah, I'm on NA East. Shifter says Fortnite is mids. It seems to be a popular game. You guys like to play it. Dun, 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 dun. All right, let's see if that's. Yeah, that's up. Okay, cool. Kidder's on. Where's here? Let's see if anyone can always ping the students. Let me know if you get the friend request.
Yeah, I did get it. I'm just gonna change my settings really quick.
Oh, okay, you're good. You're good. Are you playing on PC? Yeah.
Yeah.
Nice.
Always.
Okay. Always the PC Master Race.
Exactly. gonna upset some console kids. Why do you want ambient occlusion on phone? Why would you want ray tracing on?
Dude, do they have ray tracing in this game? RTX, really?
Yeah.
Wow, that's insane.
Oh man, well, it takes so much shit for no